can you solve this geometry challenge? Here's the question. Given this regular hexagon, consider these two vertices of our hexagon. Let's draw two segments like this. Now the area of this triangle shaded in blue is 4 square units, and also the area of this quadrilateral shaded in brown given as 7 square units. Now the question is, what is the area of this quadrilateral shaded in green? Now pause this video right now and see if you can answer this question, because I will show you the solution and the answer in 3, 2, 1. Alright, the answer to this question, the area of this region shaded in green, simply equal to 19 square units. Now the question is, how do we get 19 square units? So let's find out, and here's the solution. Alright, to find the area of this region, what we're going to do is to connect this point to this point like this. And let's call this region, this triangle right over here, the bottom part, as y. And why not? And also, let's call the unknown region as x. So this entire region, we can call this as x. Now take note, this quadrilateral shaded in brown measures 7 square units. And this triangle right over here on the bottom part is y. Therefore, the remaining triangle on the upper part is simply 7 minus y square units. And now from here, what we're going to do is to extend these two sides of our hexagon like this. Now, take note, these two sides are congruent and these two sides are congruent because this triangle right over here is an equilateral triangle, also an equiangular triangle. Now from here, what we're going to do is to focus on this triangle having an area of 4 square units. And also focus on these two segments that are congruent. Now, create a line in these two vertex like this. Because take note, if we slide down the tip of this triangle into this imaginary line, the area of this triangle doesn't change. So now we can slide this point all the way on this point, and the area of this triangle doesn't change. Now from here, take note that we have two triangles right over here, this one and this equilateral triangle, and they have the same base and the same height. Therefore, they have the same area. So the area of this equilateral triangle right over here simply equal to 4 plus y square units. And also take note that the area of the entire hexagon is just 6 times the area of this equilateral triangle. So the area of the hexagon is just 6 times 4 plus y square units. But also, we can rewrite the area of the entire hexagon as x plus 4 plus 7. Now simplify this. We have x plus 11 equals 6y plus 24. Now combine like terms. We have x equals 6y plus 13. Now we have an equation in terms of x. So if we get the value of y, we get the value of x, or simply the area that we want to find. So now let's set aside this result. And the question is, how do we get the value of y? So we will focus on these two congruent vertices. And also these two triangles. Now these two triangles, yellow and green, they have the same base and also they have the same height. Therefore, they have the same area. So we can say that 4y plus y, or 4 plus 2y, equals 7 minus y. And using this equation, we can now solve for the value of y. Combining like terms, we have 3y equals 3. Divide both sides by 3, we get y equals 1. Therefore, we can now find the area of x, or the value of this x, which is the area that we want to find. And we can replace this y as 1. So x equals 6 times 1 plus 13. 6 times 1 is 6, and 6 plus 13 equals 19. And that is our answer to this question. So given this figure, then the area of this region shaded in green simply equal to 19 square units. Now before we end this video, let's have an extra challenge. So extra challenge number 1. We have similar setting. The area of this triangle on the bottom part is 5 square units, and this quadrilateral is 11 square units. The question is, what is the area of this green shaded region? Now, this is extra challenge number 1. And this is extra challenge number 2. This is a bit difficult. So, given that the areas A, B, and C, then your goal is to show that the region A is equal to 3 times region B plus C. Now, I will wait your answer in the comment section down below. And as always, we are done.